Welcome everyone. My name's Peter Taylor. I'm a Professor of Sustainable Energy Systems at the University of Leeds and also one of the co-eyes of the Supergen Energy Network Hub that's organised this seminar. I guess most of you probably know about the Supergen Energy Networks Hub, but just in case you don't, it brings together the vibrant and diverse energy network community to try and gain a deeper understanding of the interactions and interdependencies of energy networks. And so we not only look at electricity, but also gas, heat, and in the future, potentially hydrogen. And it's led by Professor Phil Taylor from Bristol University. And we include not only academic partners, but also bring together industry and other stakeholders as well. And so I'm delighted to chair this session today, and we'll be hearing from Kumar Devnath. So Kumar is a postdoctoral researcher in the Urban Energy Research Group in the Institute of Sustainable Buildings Design at Heriot-Watt University. And his research is focused on building physics, environmental design, energy demand, and energy systems modeling. And he holds a PhD in energy systems modeling, a master's in environmental design, and a bachelor's in architecture. And Kumar was one of the Supergen Energy Network Hub's first Flex Fund grants, where he was awarded it, targeted at early career researchers. And he's used that to investigate collaborative decarbonisation feasibility in South Asian developing countries. And today he's going to present some of the emerging outputs from that work. Before we start, just a quick reminder that we are recording this presentation today. We really would welcome your participation. So if you've got questions for Kumar, then please put those in the chat. And once he's finished his presentation, we will come to those, and if you're able to post those questions live, then I'll probably come and ask you to speak and unmute. If you're not able to do that, then I'll put your questions to Kumar so that we can cover everybody who might have something to ask. So without further ado, I'd like to pass over to Kumar.
Thank you, Peter. I hope everyone can listen to me. Yeah, okay.
Yeah, everything's fine.
Okay, cool. Thank you. Welcome to my presentation, where I'll be talking about my project where I started to explore the decarbonization of energy systems in South Asia, specifically Bangladesh, Nepal, Bhutan, and India, through regional collaboration. Now, before I go into the detail of the project, I want to discuss about how the whole concept and what is the present scenario that led to the inception of this project. So, as you can see that since 1960, the carbon emission, this is data from World Bank, but as you can see, in 2005, the middle-income countries crossed the high-income countries in energy emission collectively, and in 2008, the upper middle-income country crossed the high-income countries. Collectively, lower middle-income, upper middle-income, and middle-income, even if you just add middle-income and lower middle-income, they emit more than the high-income countries now. So if we want to decarbonize the energy systems in the world and we want to reduce the emissions, we not only just have to look at the developed countries or the high-income countries, we also have to look at the global south. And global south is going to dominate the emission because of the shift of industries and also the developing rapid development of economies. Because we have seen that when the economy starts to develop from a lower income countries, as you can see in the bottom part, Cambodia, Ethiopia, Nepal, Bangladesh, Philippines, these countries are progressing rapidly, and one of the indication of their rapid progression is a direct indication in the electricity consumption. In the electricity consumption, it increases rapidly when the country develops. As you can see, when we are going towards very developed countries, the electricity consumption and the GDP growth is pretty much staying in the same relationship, and they're clustered in a same way. But if you look at the lower countries, they increase very rapidly. So it is very important to model their nuances in the the developing countries and the low-income countries, so that they acknowledge the diversity and the complexities in their energy market. And we need to do that so that we don't repeat the same mistake that led to the high emission of the present time. So our focus will be on Bangladesh. So that's why I want to give a little bit of overview on Bangladesh. So if we take half of the size of UK and put 1,239 people per square kilometer, that's Bangladesh. And Bangladesh is lying on the delta, Ganges Delta, which means it is highly prone to the effects of sea level rise. And if worst case scenario, Bangladesh may lose almost 14 to 25% of its landmass in a CV 1.5 meter or more sea level rise. So basically, Bangladesh is going to be affected by the sea level rise, which is caused by the emission. And on the other hand, you can see that Bangladesh's plan for up to 2041 is to rocket high their electricity consumption because they need that electricity for the manufacturing industry. If you search your closet, mostly you will find there should be at least one garments from Bangladesh. That means, as you can see, that how widespread the industry has reached. Now, Bangladesh's energy production currently depends highly on natural gas. I'll talk about this later, but as you can see, in the future, by 2041, almost more than 50% of the energy that Bangladesh is targeting will be coming from coal. So this is the progression from 1980s, where 54% was coal, only 438 megawatt. In 2015, it's to 12,504 megawatt, where 68% is coal. Now it's in 2020 is still it's coal dominated, but the target is to shift from here to 2041. They want to shift up to 55% coal dependency and 10% import, and 15% electricity would come from natural gas, and only 5% from liquid hydrocarbon, which is coal. Sorry, which is oil. And this huge shift they are targeting because the reserve of gas is slowly depleting in Bangladesh, so they need a reliable source of energy, and they are putting these coal plants. And as you can see, the position of the coal plants and the LNG proposed LNG plants are very south and close to the, even some parts are close in the south west. It's close to the largest mangrove forest in the world. And the reason of this positioning is that all the coal plants that are newly built and the LNG plants, all of them will be depending on mostly imported LNG and coal. Bangladesh has a very little amount of deposit of coal, so they will be highly dependent on import and other countries. So the question is that when the whole world is going away, as you can see in here, these are some of the countries' initiative to reduce the dependency on coal. Bangladesh, a rapidly developing country, is going on the opposite direction. And the reason is that Bangladesh is expected to have one of the highest jump in electricity consumption per capita. And as you know, that Bangladesh has a huge population. It's the 8th largest population in the world, and there will be a significant rise in CO2 emission due to that fact. So because of that, a huge amount of need of electricity to industrialize a agri-based economy, which is already in the transition, and that they require a significant amount of electricity. And as you can see, the energy policies, acts, and action plans in Bangladesh, these are past 10 years, they have developed so many regulation just to enable quick power purchase or development of renewable resources. And also they have developed quite quickly. They developed in past 10 years, they have developed almost 3 master plans, and they have been updating it very fast, rapidly. Within every 5 years, they're updating their goal. So their target, and Bangladesh is targeting to be 100% electricity access. 100% people will have access to electricity by 2021, this year. And one of the target was that they cannot just depend on their natural resources. They have to get the electricity from neighboring countries. And that led, one of the major change is in India in 2018. They passed a new guideline for import-export cross-border electricity in the subcontinent, and due to that change, Bangladesh can now actually import electricity from Nepal and Bhutan. Previously, Bangladesh was only importing from India because Bangladesh has the almost all sides are India, and only in the south east there is a little part of Malaysia, Myanmar, but only 20 to 30 kilometers away from Bangladesh's north, we have Bhutan and Nepal. So because of that guideline change, with the Indian transmission lines, Bangladesh can now access the Nepal and Bhutan's electricity market. And the cross-border import is expected to rise almost 8,500 megawatt by 31 and 9,000 megawatt by 41. So that's the target, but it will be only 10% of the whole electricity demand by 2040. And Bangladesh already are in talks to reduce dependency on coal plant. But when they are talking, they have already established 1,500 megawatt of coal power plant, of which almost 1,200 are newly built, and they will be operational way past 2050. So if the momentum carries on and there is no alternative, Bangladesh is going to establish almost almost 33,000 megawatt of coal power plant, new coal power plant, which will be operational way past 2050. So Bangladesh is in talks with importing electricity, hydro power especially from Nepal, Bhutan, and Myanmar, and they are also in talks to investing in solar power plants in India, because Bangladesh has a huge issue that they have a huge demand, and they also there is a financing issue in Bangladesh, Nepal, and Bhutan, which drives the whole development of such huge renewable projects. On the other hand, solar is expensive for Bangladesh, because Bangladesh is as you have just seen, that there are 1,239 peppers per square kilometers. Each part of Bangladesh is trying to maximize the food production, because the food security is always, Bangladesh is food secured, but if we replace that land with energy generation, then there is a huge problem, and Bangladesh will have to face the food security versus energy security issue. And also another one is Bangladesh is poor in renewable potential. Wind is very low. Offshore wind, onshore wind is very low, because it's a very flat country. Also, because being a flat country, you don't have much of hydro potential. You need a much more mountainous terrain to have a better hydro potential. And also, if you look at tidal or wave, it's also very low, and it's very highly expensive for Bangladesh to go in that term. It's still experimental for that region. Therefore, Bangladesh is already looking into electricity import. And on that note, this project came in, where the target was to see that how much like what's the maximum is possible for, to get from those neighboring countries so that Bangladesh can replace its coal power install capacity, planned coal power install capacity. And our project partner was ECAD and PowerCell from government of Bangladesh. PowerCell is responsible for the renewable energy guideline development and the policy development, and also they are working with a lot of projects that are looking towards the development of sustainable energy development in Bangladesh. ECAD is also doing a lot of climate change and development work. And on top of that, so now I'll focus on the area that we are looking at. We are right now we're looking at the area of not entirely South Asia. It's mostly India, Nepal, Bhutan, and Bangladesh, and that has almost 20% of the world population living there, and Bangladesh being the 8th largest and India being the 2nd largest populous country. And if you look at the electricity generation mix, Bangladesh highly dependent on natural gas, but India is very opposite. India largely 71% depends on coal, and India is also trying to change their electricity mix, generation mix, and going for renewable resources dominating. But you can see that the electricity demand in India is significantly larger than any other neighboring countries. And the interesting part, if you look at Nepal and Bhutan, almost 99% of their electricity is generated from renewable, or exactly to be exact, it's from hydroelectricity because of their geolocation. And India is already investing in Bhutan for one power plant to generate their electricity and buy them. So in Bhutan actually exports almost 74% of the total generation. In 2017, they exported to India after meeting their demand. And the concept of this whole thing was that if Bangladesh is going to import electricity, and that's just 1,160 megawatt in 2020 from India, nothing from Nepal and Bhutan, and they're talks in very little amount, like 500 megawatt of electricity they want to bring from Nepal. Still the talks are going on, and they want to increase that to 6,000 megawatt by 2041. But what I want to see that what's the potential of Nepal and Bhutan, how much hydro energy they can produce, hydro or solar and wind energy they can produce, that how much of the electricity generation, especially coal, Bangladesh can replace with the electricity import. And from that started to have gather more questions. So the first one was that what is the present renewable energy generation capacity in Bhutan and Nepal, or how their electricity demand looks like, what will be in the future, what is the economical, technical, or theoretical potential of these renewable sources in Nepal and Bhutan, and how much electricity can be generated to export it from Nepal and Bhutan. Now you must be thinking that where India went, because we can see that India is highly dependent on coal. Renewable resources, if India is generating from their sources, it's already to replace their install capacity. That's why I'm predominantly focusing on Nepal and Bhutan, because they are already self-sufficient on renewable energy, and they have a significant larger portion of the renewable generation capacity. So the first objective was to investigate the present scenario of electricity demand and supply, and then to explore the renewable energy generation and supply scenario potential, then develop the two models for Nepal and Bhutan, two energy supply and demand and emission forecasting model, and then develop a combined collaborative model between Bangladesh, Nepal, and Bhutan. and then investigate the electricity export import feasibility, and to see that how much can be replaced, how much of the carbon intensive fossil fuel generation can be replaced by import. So this was the total methodology that we worked on. India and Bangladesh already had two forecasting models, in emission and energy forecasting models. We used those, and then we developed the same model in Nepal and Bhutan. And then we developed the collaborative model to see that how the change in one country can actually affect the other country. This is one just example that it's an Excel-based control sheet, and I know many countries have 2050 models, but for Nepal and Bhutan didn't have that, so I developed it, and now we can actually cross-examine between the four countries. So with this model, we can experiment on different scenarios, and the scenario that I want to check in this project is that if Bangladesh has a high emission fossil fuel dominating scenario, which is, you can see that by 2050 Bangladesh will have almost like 6,600, almost 6,500 terawatt hours of electricity generation, and on the other hand, Bangladesh will have a electricity demand of 662 terawatt hours of energy demand, which is only 46 terawatt hour in 2050. And as you can see, that Bangladesh's emission can skyrocket to by 2050. 2050, that's almost 500 plus million ton of CO2 E. And just to give it a perspective, into 2015, France's total emission was somewhere near 470 million ton CO2. So Bangladesh is looking towards a significantly higher emission by 2050 if they keep going on their present direction of fossil fuel dominating energy mix. So in the model, in the Bhutan and Nepal model, the first task was actually to see that in a high population and high economic growth scenario, what would be the energy demand, from collective energy demand from Bhutan and Nepal. And our model shows that it will be 55 terawatt hours for Bhutan and 135 terawatt hour for Nepal. And under that situation, if what are the scenarios we have tested in this presentation? I'm going to present 6 scenarios, where you can see the first is a business as usual. There is no business as usual means there is no installed capacity that can be exported. Then it's scenario 2 is hydropower potential, economic hydropower potential. In scenario 3 is technical hydropower potential, and scenario 4 is all hydropower potential in Nepal and Bhutan. And scenario 5 is all hydro and technical solar power, and then scenario 6 is all hydro, solar, and wind potential. As you can see, the wind and hydro potential are not significantly high in scenario 5 and 6, but hydropower is dominating the total installed capacity in Nepal and Bhutan. So under that scenarios, we have seen that with all the installed capacity, with all the potential installed capacity of hydro, Bangladesh can replace its coal and oil generation entirely by 2050 if they import electricity, hydropower electricity from Nepal and Bhutan. But there is a catch here. The hydropower that Bangladesh will have to explore if they want to get the entire coal and oil generation replaced is they have to explore restricted areas and all the available regions of energy generation from hydro, which is environmentally very dangerous. and also it needs a lot of planning and engineering to actually counter that. If that's not possible, with technical maximum, Bangladesh can replace its 50% of electricity generation by 2050 with electricity imported from Nepal and Bhutan. In that case, what it looks like, in that case, if Bangladesh does that, Bangladesh's energy related GHG emission will not exceed 170 million ton of CO2, which was supposed to exceed 508 million ton of CO2e. On the other hand, if Bangladesh wants to replace its entire fossil fuel, which also adds on the gas, natural gas, Bangladesh cannot do that with the import from solely import from Nepal and Bhutan. As you can see that there is a 10% of the energy demand that will not be fulfilled. So 90% of it can be replaced. And if Bangladesh can replace that 90% and they can substitute the rest of the 10% from Myanmar or India. This is speculative in that part. If they can get from another sources, they can reduce their electricity related emission to 88.8. But even if they don't do that, still they can reduce it to 171 million tons, which is significantly lower. Now, Bangladesh is, therefore, it is clear that Bangladesh can replace its coal and oil power generation entirely with electricity import, and 90% if they can import the entire high bound of the electricity that can be produced in Nepal and Bhutan. And the electricity import in Bangladesh can reduce 66 to 83% of the projected total GHG demand by 2050, which is very, very high potential, in my view, to be reduced in a country which is one of the emerging economies and will become a large, rapidly growing economy very soon. So I was also trying to see that with that maximum potential, how much of India's decarbonization possible with that amount of energy generation? Because India is already investing money in Bhutan for one of the big hydropower plant where they are importing it from Bhutan in a much more lower scale still. And as you can see that even India explores all the energy generation in Nepal and Bhutan, still it will not be sufficient for more than 10 to 15% of their electricity demand. And it's very low for them, but still it will be helpful for them to decarbonize some part of their electricity demand. Now, it's not to compare that which one is better, Bangladesh or India, but it's just to show that India and Bangladesh can actually collaborate with Nepal and Bhutan to create a much more decarbonized energy generation in that region. And now, when we talk about this type of cross-boundary connections, there is a huge challenge that already looking in our face. So one of the biggest challenge we are, if this type of initiative goes on, will be geopolitical relation. And China is also in a part of that, because some of the rivers, as you can see in the map, are also connected from China. Intermittency of the hydro, solar, and wind energy, because in the winter, Bhutan and Nepal both see a reduction in hydro generation, but also if we look at the demand in winter also reduces in Bangladesh, not in India, in some parts of India, and definitely in Bangladesh the demand reduces because the lack of need of cooling. Another issue is the transboundary water management. Putting hydropower plants will create a huge issue on the water flow and who's getting how much, which is already a big question in that region. Energy dependency is another issue because no country wants to depend on another country on energy as such a huge and important resource for them. But again, we have seen that it is possible in Europe, in many other countries. We have seen that in many of the regions have done it. And Bangladesh being a country which will explore, which will go to the point that they will need that amount of electricity, and Nepal and Bhutan can act as a generator for the whole region. Financing is another huge issue for this type of projects, and the environmental impact is, I already talked about it, and climate change. Climate change is affecting the rainfall, climate change is affecting the river water flow, and that will definitely impact the generation. So the model that we have produced is now ready to actually explore more extensive research, is such as a climate module. We can add on them, and I have been already working on a climate module. We can work in the future with economic module, land use and food security module, and energy environment impact module, or impact on climate change on energy generation potential. And also we can look at a because these are hydropower plants, there is a chance that we can look as these power plants as a regional battery for the energy systems, where when there is a excess electricity generation, they can actually pump store the hydro and store it as a battery, rather than relying on the chemical batteries that we are currently looking at. And regional carbon offsetting potential, being Bhutan is one of the few countries which have carbon negative result, which is quite impressive. And Bhutan and Bangladesh and Nepal and that region can actually collectively work as the lungs for the whole subcontinent, and can act as a regional carbon offsetting initiative. And also, I was very interested to explore that what are the other countries or regions we can apply this type of modeling. So one of the interesting one is Kazakhstan, where I have seen that presently 90% of this Kazakhstan's energy is depending on coal and gas, but its neighbors, Tajikistan and Kyrgyzstan, has one of the highest amount of hydro potential in the world. Tajikistan has almost 4% of world's hydro capacity and 53% of Central Asia's hydro capacity. So Tajikistan can also explore such type of energy collaboration. Another one is Singapore, and 95% depends on natural gas. But being a very small country and an island country, it's really hard for them to generate from renewable resources. But their neighbor countries, Malaysia and Indonesia, although they're highly dependent on fossil fuel, but they have a significantly high land and solar potential. Because of the geolocation, they get one of the highest amount of solar exposure, which can be harnessed. And Singapore can actually look into this type of cross-boundary energy collaboration to decarbonize their electricity also. So from this project, so far we have published a conference paper, a journal paper is in under development, and also there are two dissertation projects that are going on for undergrad, which are looking at more detail in residential sector and renewable energy potential, especially hydro in Bhutan. Thank you. If there is any question, I'm open.
Great, thanks so much, Kemal. It's really good. I don't see any questions in the chat at the moment. I don't know if anybody wants to unmute and ask Kumar a question directly. If you do, now is a good chance. Maybe while you're thinking about that, I had a few questions. I thought it was a really fascinating talk. And maybe you covered this, but maybe I just missed it. So at the moment, the gas is domestically produced?
Yes, in Bangladesh?
Yeah.
Yes, Bangladesh has a huge gas deposit, but it is expected to be depleting by 2030 and 40.
Okay.
That's the time limit, and that's why Bangladesh is massively looking towards coal. Yeah.
But the coal would be imported. Or
yes.
The coal,
yes. Yes.
Okay. So that you seem to me that was. I mean, it's interesting that for all the reasons you said, but also in terms of balance of payments and what have you, that they would be looking to become dependent on, international coal markets. I wondered if one thing I don't think you did mention, I think, I don't know very much about Bangladesh, but I think they've started to build some nuclear power stations.
Yes.
What's the sort of prospect for nuclear?
Nuclear has a good prospect, I would say, because it will generate a lot of energy. Already there are 2,500, I think, megawatt of generation capacity that is targeted and expected to be operational by 2025. But the problem with nuclear is, first of all, Bangladesh doesn't have the expertise of any type of nuclear disaster. This is the first problem. It is highly dangerous because of the plants are not small nuclear, they're quite big. And we have to highly depend on Russia for the fuel and also for the decommissioning of the waste, which that means that entire system is dependent on another country. So that's why it's still a question that how much more we should establish, because if we establish this one, which is already under construction and it will go on operational by 2025, it is a big question that how much more we should establish.
Yeah, okay. Thank you. I've got plenty of other questions, but I see that Richard Aduro has got a question. So Richard, if you'd like to unmute and ask your question.
All right, thank you, Peter. Kumar, that was a very lovely talk, especially when you're looking at the perspective where we think reducing carbon emissions should be coming from the much more industrialized countries. And there's some sort of debate in that angle where they feel, let's not worry about the small countries. Let's really do a lot of actions on the bigger, countries like America and India and the other countries. But you have shown in your work that if Bangladesh doesn't do much about it, it can actually get to the position of France, which is even more than that of France. And that in this research is very outstanding. The other thing that I would like to ask is in relation to the efficiency of energy networks.
Yes.
So in your grid system, I would assume maybe all of them are connected to the grid, or maybe they have some mini grid projects. But did you take into consideration the potential of increasing efficiency in the energy networks? For example, in my country, about 30% would go to waste, and most West African countries. So instead of really building new power plants, what about working hard on efficiency measures to get the grid very, very efficient, and then to avoid either overinvestment or these import-export ideas?
Thank you. That's a very good question. So Bangladesh had a very bad leaky grid, let's say almost 20 years back. Now, the way they're developing, it's actually going into very much, they're reducing almost lower than 10%. So the grid is getting better and they're looking into developing it in a much more efficient way. The problem is also here is because the grid is not just Bangladesh's grid is not going to look at, it's going to use India's grid, Bhutan's grid, and Nepal's grid. So in this model, we didn't explore the grid efficiency in a more connective manner, like a grid model was not there, but the grid efficiency was there in the calculation to see that how much is wasted. So we acknowledge the wastage of grid in that calculation when we developed the connectivity between different countries. We did that.
All right, thank you.
Thanks very much. I think we also have a question from Chan now. you'd like to unmute and ask it.
Yeah, thank you, Professor Taylor. Yeah, and thank you, Kumar, for sharing this very interesting work with us. So I just have a question about a particular type of technology. So it can be very diverse in sense of energy storage. So for example, in developed countries like UK, we are looking at several types of energy storage like batteries, thermal stores, etc. So, I mean, in terms of electrification for regions which you discussed, so how do you see in the near future or at presently they are employed or used to help with managing this kind of influx of renewables and in particular for other sectors like transport, etc. So this is something I'm looking at the moment, which is quite advanced for transport. But I think for integration of renewables, energy storage has played, an important role in several decades at least, I think. Thank you.
Thank you. That's a very good question. And if we are looking at transport, especially in Bangladesh, Bangladesh's transport is largely depends on private car and buses and public buses, but they're very packed. It's a high density country, population wise. There are use of electricity in, we don't have Tesla, that's for sure, but Bangladesh do have makeshift electric vehicles, which are three-wheelers, runs on motors. And they use a significant amount of energy from the grid to charge these batteries. And these are like three-wheelers, which were rickshaws before, and now they're converting it to electric battery run, this type of vehicles. And they are everywhere now. And they flooded, like I went to one part, north part of this Bangladesh in 2014, there was none that type. When in 2016, I went there, every single one of them was like that. So it is shifting very rapidly. And we have a lot of solar panels. It's small house rooftop solar panels, especially for the village areas and the remote areas. And we also have some mini grids in Bangladesh for the remote locations or the communities. The problem here is that we're talking about a country which is going from 20,000 megawatt of installed capacity in 2020. They're planning to go in for 2041 to 60,000, which is like never done before in their past history. And they're targeting doing it within less than 20 years. And that's why this type of small initiative, even if they're collecting to in a large amount, it's not impacting largely in the manufacturing industry-led economy. That's why Bangladesh is looking towards large energy generation. Also, there are incentive initiatives for this type of small ones. Now, in terms of battery, these all rooftops has small batteries. They are not grid connected. Very few of them, like very few big solar panel projects are grid connected yet. Only I think 2 so far. I may be wrong, but still the majority of the solar rooftop systems have small batteries, which are regular batteries they use for their use. And there is no big battery yet, but there is potential. The problem is here, it's a high capital cost sector for Bangladesh. And the batteries has a lifespan, which also they have to consider. And from my point of view is that these batteries are highly dependent on materials that are under debate of how ethical those materials are. And also in case of Bangladesh, how much of it is locally producible is also another question. But they are in talks to find this type of alternatives, and they are exploring, and maybe there are more in the future, but at present there is no that scale of integration of such storage, and thermal storage is not there yet. as far as I know.
Yeah, thank you, Kuma, yeah, for this very insightful comment. So in fact, like in the UK, we're looking at something more prolonged in terms of energy storage, which lasts for many more years. So like a pumped heat energy storage and a gravity energy storage, they are very different to battery chemistries. They will degrade and they affect by the cycle, induced, etc. But I think this is can be something examined in the future, especially for remote places where energy storage will play a critical role. Yeah, so thank you.
That would be really interesting to see alternative battery storage systems. And yeah, as I was describing, because of the hydro potential in Bhutan and Nepal, they can actually also use the same hydro plants as pumped storage to actually work those as a battery for the whole region. So maybe that's another issue, potential we can explore. But yeah, you're totally right. Thank you.
Definitely, thank you.
Thanks both, that was really interesting. We've now got another question from Paul.
Thank you, Peter, and Kumar, excellent presentation. I've learned a lot this morning. It's really interesting, and I think you're attacking one of the main issues that we've got, isn't it? Is how to get developing countries from a position of relatively low consumption to a normal first world level of consumption without going through that sort of fossil fuel dependency that the rest of the world has gone through.
Yeah.
So it's a really important issue that you're tackling here. So I think you've partially answered my question, which was really about how much more potential is there in Bangladesh for and the region for solar power, because it does seem like solar power is quite a good match for the load profile in that area, if it's mainly cooling and daytime industrial. But is that saturated, or is there a my perception is that a lot of the issues around here are about finance and where the finance is directed. And while we have companies and countries who are prepared to finance coal and gas plants, that actually getting finance for small solar projects is much harder. But what if we actually manage to change that? What level of penetration do you think you could get for solar?
The solar penetration, thank you for the question. It's really relevant, and the solar penetration in scale of the solar home systems are quite extensive in Bangladesh, especially in the rural areas and the remote areas. It's not saturated yet, but it's going to the point that actually now the system which is financing in Bangladesh, ITCOL, and they are showing quite good level. I'm not 100% sure that it's saturated or not, but definitely they are doing it much rapid speed. I have just seen the recent numbers; they're quite impressive. Now, the problem with Bangladesh is that there's urban areas that Bangladesh has. It's highly dense, so you have very high flats, like 10, 20 stories of flats, and you can see people are living there. The amount of roof they have and the amount of generation energy they need is not comparable to a significant amount yet. And another issue is the manufacturing need is so high that most of the electricity dependent or the energy dependent in manufacturing industries have captive generation, and they use gas to actually generate their own energy. So from this type of issue, some companies are looking into bigger solar power plants within the premises and trying to actually generate some part of their energy. But I haven't seen entirely an industry going towards solar or this type of financing is one of the issue, but also another issue is that the intermittency, because these manufacturing industries needs a continuous supply of energy, and these type of intermittencies always give them like it's hard for their deadlines and all things. So these are the problems that they're facing, and the government is also facing the same issue.
Yeah, I mean, it's interesting because, I mean, hydro is particularly a good match for other renewables in that, quite often you're more restricted by the amount of electricity that you can provide rather than the power. Particularly at some times of year, like you said, winter's difficult for
Yes.
hydro. But I was just wondering, there are other sort of solar technologies coming along that have been deployed, partly in the UK that, things like mixing solar and agriculture together. If you put solar panels high enough, you can actually increase crop yield sometimes. And also floating solar is another one possibly that would work for Bangladesh. I don't know. Is that?
Thank you for mentioning that.
Or is that something that might happen?
No, that's a very good point. Bangladesh already established a 500 megawatt of solar irrigation project, where they are actually, this is a government project which been, I think from 2015 it's operational, and they are looking into this type of solar induced irrigation, because the one of the big demand in Bangladesh came from, in the past, was from irrigation. If the irrigation starts in the same time when the manufacturing industries are starting, that started a big. So they shifted that by encouraging the farmers to define time to use it. But also this 500 megawatt project is ongoing, and it is trying to replace that irrigation peak with that type of solar generation. The problem with Bangladesh is that first of all, that amount of solar they are getting is not sufficient for huge amount of electricity generation. It's maybe sufficient for a household to rely on, but not sufficient. That's why Bangladesh wants to even put solar plow plants in India's land. They want to invest in there, because they have a higher generation capacity. As I was saying, that Malaysia or Indonesia, they have a significantly higher potential of solar, whereas Bangladesh has lower than that. It's not very low, but it's lower than that, but compared to how much they need. And in terms of the 500 megawatt project, it's targeted towards specifically irrigation. And again, the question is that what about the manufacturing industry, which is now dominating like for the economy right now. So that question of higher amount of energy and the continuous energy is still there for the manufacturing, even if we take off the agriculture part from the equation.
Sure. Yeah, thank you.
Okay, great. Thanks, both of you. We're coming towards the end of our time together. Does anybody have a last question that they'd like to pose to Kumar before we close? I'm not seeing any hands or any unmuting of microphones. So I'd like to thank Kumar very much for his presentation today, and thank you to all of you for joining and making it such an interactive session.